Welcome! Today we're exploring the revolutionary ideas of a trailblazer in the field of artificial intelligence, engineer Fabio Di Bello, known for his groundbreaking work in the quest for artificial general intelligence, or AGI. Fabio Di Bello is an engineer and a visionary who has devoted his life to the study and advancement of AI. Our journey today is based on his seminal research article, a blueprint for creating AGI that could change the landscape of AI as we know it. This article, A Beacon in the Field, provides a comprehensive overview of his vision for AGI, from its conception to its potential real-world applications. The impact of Professor Di Bello's work is significant. His ideas and theories have sparked conversations and ignited hopes of creating machines that not only mimic human intelligence, but also understand and interpret the world as we do. The implications are enormous, from solving complex problems to revolutionizing industries. So buckle up as we dive into the fascinating world of AGI as envisioned by Professor Di Bello. It's time to unravel the mysteries of AI and explore the enigma that is ChatGPT. Have you ever wondered how ChatGPT, a language model, can generate such accurate and engaging responses without having any real knowledge or logic? Welcome to the fascinating world of artificial intelligence, where machines mimic the human ability to understand and produce language. This is the realm of ChatGPT, a language model that has revolutionized our approach to AI and language comprehension. Now you may ask, how can ChatGPT produce such compelling responses without possessing actual knowledge or logic? The answer lies in the intriguing world of neural networks and deep learning algorithms. These are not your traditional neural networks, but ones that have been fine-tuned and enhanced to create large language models, LLMs, like ChatGPT. What's fascinating about ChatGPT and its ilk is their ability to turn words into numbers, to churn through vast amounts of data, and to generate responses that often leave us amazed. But it's essential to remember that these responses are not born out of genuine understanding or logic. Instead, they're the result of complex mathematical models working behind the scenes, analyzing patterns, and predicting outcomes. However, this doesn't mean that ChatGPT is flawless. While its performance can be impressive, it does have its limitations. For instance, it lacks real-world understanding and the ability to construct a functional representation of reality. It's like a brilliant actor delivering lines without truly understanding the context or emotion behind them. But what if we could bridge this gap? What if we could imbue AI systems like ChatGPT with logic, common sense, and a deeper understanding of the world? This is where the concept of neuro-symbolic AI comes into play. It's a revolutionary approach that combines the strengths of symbolic and neural methods, potentially leading to more intelligent and capable machines. So as we stand on the cusp of this exciting new frontier in AI, it's time to delve deeper into the enigma that is ChatGPT. How does it work? What are its capabilities? And most importantly, where is it heading? Let's dive in and unravel the enigma that is ChatGPT. At the heart of ChatGPT lies a unique combination of mathematical models. The engine driving ChatGPT is a deep learning algorithm called a transformer. This model has been trained on a vast corpus of text data, learning to predict the next word in a sentence based on all the preceding words. It's a bit like a highly sophisticated game of fill in the blanks, where the model uses probabilistic reasoning to guess the most likely next word. The transformer model is a type of neural network, a computing system inspired by the human brain. It's composed of layers of interconnected nodes or neurons that process and pass on information. Each neuron is associated with a specific weight, which determines the importance of the information it carries. In the case of ChatGPT, these neurons are trained to recognize patterns in language. For instance, if the phrase "the cat is on the" is inputted, the model would likely predict roof or mat as the next word, based on patterns it has learned from its training data. But what sets ChatGPT apart is its use of the downstream approach. Instead of being explicitly programmed with rules or logic, ChatGPT learns from the ground up. It's a lot like how a child learns language, not by studying grammar rules, but by listening, imitating, and gradually understanding the patterns and nuances of speech. This approach represents a significant departure from traditional AI methods. Earlier models relied heavily on handcrafted rules and logic, which often fell short when dealing with the complexity and variability of natural language. The downstream approach, on the other hand, allows ChatGPT to adapt and learn, continuously improving its language understanding and generation capabilities. The mathematical models used by ChatGPT, from the transformer neural network to the downstream learning approach, represent a powerful blend of probability, pattern recognition, and adaptation. They are the gears and cogs in the machine, enabling ChatGPT to engage in complex language tasks, from answering questions to writing essays. These mathematical models form the crux of ChatGPT's language processing capabilities. While ChatGPT is a powerful tool, it's essential to understand its capabilities and limitations. Diving deeper into the world of ChatGPT, we find a tool that is versatile in its applications. It shines across various domains, one of them being clinical practice. It's not uncommon to find ChatGPT being used to interpret medical language or even assist in patient communication. But this isn't where its capabilities end. With a knack for understanding and generating human-like text, it's found a home in customer service, content creation, and even gaming. However, as we explore the depths of this AI, we must also acknowledge its limitations. Despite its impressive performance, ChatGPT isn't perfect. One of its most significant challenges lies in the quality and reliability of its generated responses. While it can produce text that seems contextually accurate, it may falter when faced with more complex scenarios. The absence of real-world knowledge and experiential understanding means it can't always provide accurate or sensible responses. The AI's lack of a functional representation of reality also poses a problem. It can't reflect on its past interactions or learn from its mistakes in the same way humans do. It doesn't understand the world or its experiences. It merely processes and generates text based on patterns it has learned. Then there's the issue of scalability. While it's tempting to think that increasing the size and nature of the dataset and training may lead to improved answers, this isn't necessarily the case. The challenge is more about abstraction, generalization, and symbolic logic, which are integral to what we call common sense. These are aspects that aren't easily learnt or improved upon by simply increasing the volume of data. Understanding these capabilities and limitations can help us harness the power of ChatGPT more effectively. By knowing what it can and can't do, we can better utilize ChatGPT, ensuring it's used in areas where it can truly shine, while being cautious of its shortcomings. And with this understanding, we can continue to innovate and push the boundaries of what AI can achieve. Despite its impressive capabilities, ChatGPT lacks something crucial: logic. This is a system that can generate engaging and coherent text responses, yet the absence of real-world understanding and logical reasoning can lead to some glaring inconsistencies in its responses. While ChatGPT can mimic human language patterns impressively, it doesn't truly comprehend the words it generates. It's like a skilled parrot, repeating phrases without grasping their meaning. This lack of understanding impacts the quality and reliability of the responses it generates. For instance, it might produce a beautifully crafted answer that, upon closer inspection, doesn't hold up to logical scrutiny. This absence of logic in ChatGPT raises some fascinating questions about the nature of logic itself. Is logic something that can be taught, or is it an inherent property of conscious beings? Can logic emerge spontaneously within a vast neural network, or is it something that evolves from experience and interaction with the world? These are complex questions, and the answers are not straightforward. Our understanding of how logic developed in humans is still incomplete. We know that human logic is closely tied to our experiences and our understanding of the world. But can a machine like ChatGPT, which has no experiences and no real understanding of the world, develop a comparable form of logic? ChatGPT, despite its lack of logic, serves as a powerful tool for generating text. It uses a computational approach to language, converting words into numbers and processing them within its model. This allows it to generate text that appears logical and knowledgeable, creating the illusion of understanding. Yet, this illusion is just that, an illusion. Without a real-world understanding and the ability to reason logically, ChatGPT's responses can sometimes seem off. They can lack the common sense and logical consistency that we associate with human conversation. This shortcoming doesn't mean that ChatGPT is a failure. Far from it. It's a testament to the incredible advancements we've made in AI, but it also highlights the challenges that remain. The question of logic in AI systems is a puzzle that remains unsolved. The future of AI might lie in a new approach called neuro-symbolic AI. This innovative technique is a marriage of the symbolic and neural approaches to artificial intelligence. But what does this fusion entail? Let's break it down. The symbolic approach to AI is rooted in formal logic and rules. Picture a vast library filled with volumes of rule books, each one governing a different aspect of cognition. From language understanding to problem solving, these rule books guide the AI in making sense of the world. But as you can imagine, this approach can be rigid, often struggling with ambiguity and the fluidity of real-world scenarios. On the flip side, we have the neural approach, which models the functioning of the human brain. It's a playground of interconnected nodes, constantly exchanging information, learning, and adapting. This approach is excellent at handling ambiguity and learning from experience, but it lacks the concrete rules and reasoning abilities of the symbolic approach. Now imagine combining these two, the rule-based precision of symbolic AI with the adaptive learning capabilities of neural AI. That's the essence of neurosymbolic AI. It's like having a brain that not only learns from the world around it, but also has access to a vast library of rulebooks to guide its learning and decision-making. The potential of this approach is enormous. Think of the complex problems we could solve, the nuanced language comprehension we could achieve, and the leaps we could make in machine reasoning. Neurosymbolic AI could revolutionize the field, challenging the limitations we've encountered so far. But as with all advancements in AI, it's a journey of exploration and learning. There are challenges to overcome and questions to answer. How do we best integrate these two approaches? How do we ensure the system can effectively balance rule-based reasoning with experiential learning? With the advent of neurosymbolic AI, we could be on the brink of creating more intelligent and capable machines. It's an exciting prospect, one that promises to redefine our understanding of artificial intelligence and its capabilities.